Alright, so I thought I'd continue the Stormworks Basics car tutorial, and we get into stoichiometry. Somebody had asked for some help with stoichiometry last week, so I thought it'd be good to get into that. So currently, let's review our build. So this is the ended off with the automatic transmission tutorial. If we look over here, we're controlling our RPS with the WS. We come into a clamp here, we go to air manifold, and we're doing a very simple calculation of x times 0.5, so we're splitting our air in half, so we have half the fuel that we have of air. This is a very basic way to do this. This has some benefits. One is just simplicity. As you can see, it's very easy to do. Two is that since we're not putting a ton of fuel in there, it allows us to keep the heat down and in control. This isn't a huge deal in a car because if you think about a car, you're going to rev it up to a high RPM, and then if you make a turn or if you stop and stop and go or whatever you're doing, you're going to probably rev back down. When you have something like a boat or an airplane where you're at high RPMs or RPS for a long period of time, you're going to start to build up heat, and so when we start to get into stoichiometry, and especially when we start to get into like supercharging. So essentially supercharging, to kind of go through the theory, is what you're doing is using an impeller to pack in more and more air. And the more air you have, remember you're going to have about half of the fuel, that you're going to have air. So if we say double the air, well, we'll double the fuel we're burning. Well, we're also making more heat. And so then we start running into heating concerns. So one of the reasons why I like to start with this really simple, just splitting the air in half, is it helps to keep our heat in control. So let's go ahead and we'll do the stoichiometry for this engine. So I copied the formulas from another build, so I'm just going to do Control V. And this is all the formulas we need. So let's go through it really quick. I forget exactly where I got this. If I can figure it out, I will credit it. But, so let's look at these numbers. So 0.2 stoichiometry is where we want. So we could set this. 0.2 is where we want, so we're going to leave that where it is. If we look up at our composite reads, we have 1, 2, 3. 1, 2, 3 is going to come from our engine. So let's quickly save this. And let's go to, we want select tool, and let's go to the engine node. Actually, we want the logic. Let's go to composite. Let's go here. So we get composite data. So value 1 is the air volume. Value 2 is the fuel volume. Value 3 is the temperature. So if we go back in here and we look, so this is our air volume, fuel volume, and this is our temperature. So these functions here, these pieces of information allow us to plug it into the formula, and then it allows us to, it allows the engine to automatically modulate based on what the changing conditions are. So as temperature changes, you need to change air and fuel to maintain stoichiometry. Also, if you were to, for example, let's look at a ram. So here we have a ram air scoop. So if we put this on instead of this air filter, the more air that we pack in there, right, we need to compensate by adding more fuel. So this will automatically do that. So if I were to trade out this air filter, which we will at some point, for a ram, the faster I go, the more air I'm packing in. Well, the more air I'm packing in, it allows me to pack in more fuel. And so that allows me to get more horsepower out of the smaller engine, and byproduct that being heat. So let's go back in. So so we want to connect these nodes to a to the engine composite. So I believe that's down here. Here's engine. So let's grab this. We'll hold control so I can attach to all three. 1, 2, and 3. All right, so now what I'm going to essentially do here is I'm just going to move this out of the way for now. I'm just going to move it up here, and this is going to be my new section here for our stoichiometry. And so I'm actually not going to connect this yet. What I'm going to do is I'm going to save it, update, and save, and I'm going to launch the car. And let's drive this car around. We'll kind of note the performance of the car. So let me try to remember how to operate this. Okay. So we have our automatic transmission now, so we don't have to do much. So let's just take it down the train tracks. Alright, so let's note the performance. So the main thing we're going to want to note here is when we get up to max speed, essentially. So do I have an I don't have a speed on here, but we don't really need speed. We can check our wheel RPS, and that will give us a good notion of our speed. All right, so we're at top gear, fourth gear, and we have just under 8 RPS on the wheel. So that gives us that, and I could actually figure out the diameter of the wheel if I knew the speed, because you have a certain RPS to the wheel. That's, you know, essentially a gear. So we're up to about just under 8 RPS. All right, so now let's see, by plugging in the stoichiometry equation, let's see what our performance does. So let's go back in. All right, so now let's look at some of the things we want to do. Now, one trick I'll do, it's not too much of a trick, but if you use an ad block, it allows you to move a piece of information around. So for example, RPS. So I'm just gonna, so I need my, actually I don't want RPS, what do I want? So if you look at there, I made a note, X equals throttle. So we have X, Y, and Z. This is the X here. So we're gonna actually move our throttle here. So let's find, we might actually, no, we don't need to do it, but yeah, let's just do it regular. That way it's easier for you to see. So right here, this is our throttle. So I'm gonna hold control, I'm gonna do X and connect that to the X. So that's my throttle. That's going in there. All right, and I think I have everything I need. So I have 1, 2, and 3. So that's air volume, fuel volume, and temperature from the engine. And then I need to put in my throttle. All right, so now the last two parts here is what are these going to? So these are going to my air and my fuel. So I need my outputs for my air manifold, my fuel manifold. I'm going to connect those. And I think everything's connected. So let's update this and let's test it. I should have checked, I should have shown you how the engine was running on, let's actually do that so we can cross-reference it a little bit. Let's go here. Let's just really quickly, I'm just going to reconnect to air and fuel the way it was. So one reason I kept this here is so that you can easily just go back to it if you want to. Also for my sake here, this way I can easily go and look at it. So let's just start the engine. All right, so and we're going to look at the, we're going to get the engine tooltips here. So I don't even need to do page up, but all right, so we have an air-fuel ratio of 13.7, stoichiometry of 0.17, so it's a little lower than we want. Efficiency is 98.7, exhaust 100%. Okay, so you'll notice when we do the stoichiometry equation, that 0.17 will be 2. All right, so let's jump in. I don't need to jump in the driver's seat. I need to recall it. Okay, so now let's connect that the stoichiometry section back up here. All right, so let's update and spawn it and make sure that I connected everything. It should start. Okay, so we're started. Let's go over here and let's look at it again. So as you can see, we went from a stoichiometry of 0.17 to a stoichiometry of 0.2, which is where we want it. You notice our efficiency went up by 0.1. So that seems negligible, but as the temperature rises, as air volume increases, that's going to you know, potentially change and give us greater efficiency. All right, so let's go in the driver's seat here. Let's drive down. Remember we had like I think it was like 7.98 was where we topped out here on wheel RPS. So we're just going to use wheel RPS as kind of our gauge of our speed. Remember, because if we know the wheel RPS, that's actually how a speedo works IRL, is you take it off the wheel RPS. All right, so as you can see, our speed is a little bit higher, but not much. So we got a little bit of speed, but that's fine. All right, so let's take this back. So our engine's running more efficiently. All right, but we didn't gain much speed. Well, one of the reasons we didn't gain much more speed is we didn't actually add any more power to this engine. We just made it run more efficiently. So let's take a ram. Let's put the ram on there. Remember, this is going to allow us, as we go faster, it's going to allow us to pack more air in. Well, with this stoichiometry equation, that's going to automatically add more fuel to our engine. All right, let me spawn it. All right, let's see where we get here. I might have to remove a clamp, but we'll see about that in a second. All right, so let's start going. And so we are at 7.99 for wheel speed there. Alright, so we're going to let it accelerate. Try not to steer too much here. Alright, now we're not going terribly fast, so it might not be adding much air pressure in there. Yeah, so it doesn't look like it's adding much air pressure. But that's what a ram would do. So for example, I have an airplane that has this in it, and that has a ram. And so that's actually adding more more air, so it's giving it more efficiency, but that's also going 200 knots. So let's try another. We'll do another test here. We'll add another air. We'll add a air scoop. Okay, so the velocity might be too slow on this to really add much more performance, but then what we're going to do is we're going to go ahead and we're going to supercharge this. So in real life, a supercharger uses a belt off the crankshaft to turn an impeller pump that allows you to pack more air in there. And the more air you pack in, the more fuel you can pack in, therefore increasing horsepower. Alright, so let's see if this... Okay, so look at our wheel RPS. We were at 7.99. Well, with this air scoop, we're now up to 8.6. So we were able to increase our horsepower and increase our power by doing the stoichiometric equation, because it's automatically changing our fuel for how much air we're packing in there. Alright, so let's go back. Alright, so next thing we're going to do here is let's go ahead and... It's going to be a little bit ugly, but yeah, we're not trying to make this pretty. We're just trying to make it functional. Alright, so let's add a pump. Alright, we want to make sure it's facing the right direction. So I'm just going to do an electric pump. And I'm trying to see how I can... Okay, that's why it's in the way. Okay, let me go... Alright, we're going to have to root this a little bit. Okay, electric pump. So we're just going to do electric pump. Now, you can do things like belt-driven pumps or impeller pumps off the crankshaft. But one of the problems you run into with that is that if you did one off the crankshaft, you can't start it because the engine's not turning yet. You're not putting air through. So then you have to do a bypass valve. A valve is, you know, if we take up a valve here. Yep, let me spell it right. There we go. If we look at a valve here, it's essentially... You know, it's 2x4 almost. You know, it's 2 blocks wide, and then you have 2 blocks up. So it takes up a ton of room. So for something like you know, if you have a large ship, it's not a big deal. If you have a small car, you start to run into space problems with that. So let's go like that. I think I have infinite electricity on at this point anyways, but we're going to do that. And then I'm going to do a constant. I don't know if I have a constant on. Let me see if I already have a constant on. I don't think I do. Let's just do, so if the driver's seat is occupied, let's go ahead and that'll turn on the pump. So that's not great. If we jump on the seat, it'll probably kill the motor, but let's see what this does performance-wise. Actually, I don't want to do that. Let me do, I have to wait until it drops. Okay, let's do this. So instead of the seat occupied, let's go to the 6 key. 6 key, remember, starts the engine. Let's have that, so if the engine's on, it will keep that pump on. Alright, so let's jump in the seat. We'll go 6. Alright, now let's look at our pump here. Okay. Alright, so that's not showing any airflow now, but we'll see as we get moving if it's starting to push air. Take the brake off. Alright, so let's look at our fuel pump. So this is supercharging. So we're adding air in here by having this pump blow air in. All right, now look. So we went from, it was like 8.66 to 8.77. So we've increased our speed again by supercharging. Now the benefit of having that stoichiometric equation there is, as you can see, I changed how this engine runs like 3 times. I put on a ram, I put on the scoop, I finally supercharged it. And that allows me to change it without having to change any of the parameters in the engine. It automatically does it for me. So as you can see, we've gone up 0.11 RPS on the wheel. All right, we actually, as you can see, we're going quite a bit faster than the original vehicle by doing the stoichiometric equation. All right, now, like I was saying, you're going to get things like, because you're able to force more fuel in this, you're going to start to increase heat, so you might have to start thinking about doing things to, have more robust cooling systems in your engine. So let's see if we want to do something else here. Try to think. So we've added that. Let me double check something. I want to make sure that I'm not artificially throttling the engine here. That's clamp fine. Okay, good. I just want to make sure I don't have a clamp. So as you can see, this is automatically changing essentially the fuel parameter based on how much air we're putting in. So the more air we force into the system, it's automatically going to change the fuel manifold. So this wouldn't work very well with an equation like this, with a very simple equation like this. So as you can see, we were able to increase our output by a little bit. It wasn't a ton. I'm trying to think what my numbers were there before. I can't remember the numbers we had before, but we went, I think it was like 7.9? Yeah, we went from like 7.66 RPS to what was the end? I think we had 8.77. So let's do a quick calculation. All right, so we were at I think it was 7.66 divided by 8.77. So that was I'm trying to think, that's not 87%. I'm trying to do the percentages off the top of my head, but so we were able to add, it's not that high. It might be 10-15% horsepower. We're essentially able to increase it by that much. So let's let me see. I think let me see if I think I have the torque on there. So let me look at the torque. So wheel RPS torque. Okay, so let's look at our torque here and see the torque difference that we're able to achieve initially and the torque we were able to achieve. That's going to give us the best output, the best idea of how much power we were able to add was torque. So let's look at our torque here. We're going to do final gear torque. So once we get up to max wheel RPS, we'll see what the torque is. And so we'll go back to our original car and we'll see the difference in torque. That's actually gave us the best representation probably of where we're at. So let's wait for it to get up to about 8.77 was where we capped out. And so we're at 48.47. Okay. I'm going to save this really quick. Okay, so it'll be Storm. Okay. Stormworks Basics, AFR car. Okay. Air fuel ratio car. Okay. And so let's load our other Stormworks Basics car. So that was our auto trans there. So what do we have? 48.47, I think, if I remember right. I almost already forgot it. So let's see what our final wheel RPS is and what our final torque is. So this engine should be more powerful because we're able to stuff more air in that engine. We're able to get more power out of it. So we're in 4th gear. Let's get up to max speed. You can already tell this old car is much slower. I think it was about, yeah, so it was 7.99 I think we got up to last time. Yeah, so let's let it get to 7.99. Let's look at the torque. That torque's the same. But we got a greater RPS, so we're able to get more speed out of this car by doing the stoichiometric equation. So as you can see, it's not a huge amount, but as you get a larger motor, you're going to be, you're going to be experienced with that's going to give you some, you're going to get greater efficiencies with that. It really, as you get a large motor, really becomes apparent how much you can change that power of the engine. For example, my ships, one of my ships I supercharged, and that added about 6 knots onto a huge ship. So that's about it for this video going into the stoichiometric equation. I'll just quickly do a fast kind of overview. So we went in here and we added the stoichiometric equation. So let's say you want to add this on one of your own builds. All you really need to do is if you copy all of this here is all you need. So just remember you want to connect this to your engine, AFR, or your engine composite. And you want to add right here, it says x equals throttle. So you want to take whatever your throttle is. In my case, it's the PID dictating the RPS. And that's going to go to the x value. And then you can plug that into your air. The top one's air and the bottom one's fuel. And that's going to automatically modulate your values to give you whatever you're setting as your desired stoichiometry. All right, so thank you for watching.